So globally when we speak, if these three are the primary energy sources, globally they are equally, almost we can say equally dependent, oil, gas and coal. The three are parallelly going. But when we come to India, our major portion comes from coal. We don't have reserve of other two energy sources. So one issue arises here about the energy security. Now, you see the world primary energy consumption, if you see the entirely, what is the total energy consumption of the world? They say it is about 583, but now it has crossed 620 hexajoules. So if it is 680 or 600, or let us say average 600 hexajoules, out of that globally we consume about 6%. Only. Out of that we consume about 6% only global energy consumption. Even then, we are the fifth largest consumer of energy. As I said, growth rate, the global energy growth rate of 1 decade is only 1.6%. That means every year their energy demand in the world is going at the rate of 1.6% only. Whereas for India, it is going at the rate of 5.2%. And it is to grow further higher. So our energy demand is going to increase further. Now, top 10 countries consume about 65% of the total energy only. And top 4 countries, 50% of the energy. So this energy distribution is not uniform. The other energy challenges, energy security. Coal to remain, Niti Aayog published a paper, the energy security plan or energy plan for IESS for 2047. They also indicated by 2047 also coal is going to be the only dependent energy source for India. Next, oil dependency on foreign supplies and quality of coal. Quality of coal, we know it will go on deteriorating. Energy access. India has done very good in terms of energy access. The per capita energy consumption is only 24.9 gigajoules versus world of 75.7 gigajoules. So it is per capita is less, but quantum wise we do consume a much. Because of blue flame revolution, cooking clean gas is being able to supply to every household and 100% electrification for all the areas. Energy demand. The energy demand growth rate for total energy is 5.2%, as I discussed, and electricity shortfall. If we say that coal, all these primary oils, they are mainly for industrial applications and transport applications, but as a domestic consumer, I only demand the sophisticated form of energy, that is electricity. Now, in electricity sector, the shortfall in 9-10, when I started working with the council, it was about 10%. Now, it has come down to 0.5% only. That is only in the electricity demand factor. Clean energy access, we are doing pretty good in terms of clean energy. The solar energy addition is increasing highly. But overall, as the energy intensity of our country must reduce. Energy intensity is nothing but quantum of energy required for per GDP output. So if energy intensity of a nation is coming down, that is nothing but an indicator that we are consuming energy efficiently. So energy intensity is the measure of energy efficiency, and there is a declining trend on energy intensity factor. Now, if as a country we see where do we consume all the energies, about 56% of the total energy goes to industries, and followed by transport, residential, commercial applications. So for us, we are the major consumer, so we are taking about 56% of the total energy. This 56% again In different industries, it is distributed. Of course, there are industries like power or the energy transition industries, a thermal power plant, a refinery. They are only converting one form of energy to other. In the process industries, iron and steel we are the major consumer. Of course, transport, because a lot of road transport dependency, we have also a major share on the energy use. Now, coming to energy efficiency and conservation. If you talk about the policy regimes, the energy efficiency in 1964, the department was established in NPC. Till that point, there was no activity on energy efficiency in India. After that, in 70, there is a fuel policy committee in the planning commission set up, 78 petroleum conservation research association. So all these activities finally led to 2001 when the Energy Conservation Act was amended or Act was notified. After the Energy Conservation Act in 2001, since last 2 decades we can say there are a lot of developments has taken place. In lot of rules, regulations, guidelines has come up to all the industry sectors based on which we are doing so many activities. Now, in NPC, if you see, we are talking a lot about the Bureau of Energy Efficiency, the energy efficiency. Another 2-3 years, this energy efficiency word is going to be replaced by resource efficiency, because now it is not only energy, there are other resources which are required for industrial production also. So maybe after 2-3 years we will talk about, because there was a draft guideline by the government on the national resource efficiency policy. So later on we will be transiting into resource efficiency guidelines rather than energy efficiency. Now this is basically the distribution of guidelines under the Energy Conservation Act, where we are focusing on energy efficiency processes. As I said, there are mainly these 5 sectors: industry sector, domestic sector, agricultural sector, commercial sector, and transport sector. These are the consumers of energy, total input energy. And till now, the government has brought guidelines for every sectors to reduce the national energy demand. If you see the industry sector, again it is large scale industry and the MSME sectors. So in the large scale industry, we know very well about the PAT scheme, perform, achieve and trade. SAIL is a designated consumer under the Energy Conservation Act. So SAIL also has to comply with the PAT scheme guidelines. For MSME, because they are not large scale industry, the financial capability, the financial muscle power is not that as large scale industries. So they need lot of support from the government for demonstrative project which brings in energy efficiency benefits. So the UNIDO, the MSME, DCMSME office, they are in association, lot of schemes are being implemented. We are also a part of it. 2-3 schemes we will discuss in the latter. Domestic sector, basically we all are aware about the star rating of the appliances. So many appliances are under the star rating guidelines. Under the star rating guidelines, there are 2 categories: mandatory star rating appliances, voluntary star rating appliances. If appliance is under the mandatory activity, so for manufacturing and selling of that product in India is mandatory. Then Eco-Nivas. Eco-Nivas is a guideline for construction of a building which will bring down or which will have a low carbon footprint. That is a guideline. Under agricultural, AGDSM, that is agricultural DSM activity, because in agricultural activity basically they are targeting the electrical pumping stations. We need to pump water for agricultural distributions. So agricultural demand side management activities. Again, under the commercial sector, basically there are 2 things. One is buildings and the MUDSM. Buildings, again ECBC, Energy Conservation Building Code. Now that ECBC has been amended, the draft is on the website, inviting suggestions. Once the draft is finalized, again the revised ECBC will come up. Rating of buildings similar to the products, and in the municipality sector, basically two programs running, that is street lighting replacement with LEDs and the pumping, municipal energy efficient pumping replacement program. Under the transport sector, road transport, railways, there are two categories. For road transport, it is CAFE and FAME. So BS3 to BS6 transition, star rating of the tires. Still now it is under the voluntary, that is why we are not aware, but the vehicle tires are also being star rated based on their energy efficiency. Railways again on traction and non-traction. So these are the 5 sectors and all the schemes being promoted by the government for energy efficiency. But as a large scale industry, we are only concerned about the industrial sector, which is PAT scheme. Of course, as a domestic consumer, the buildings, Econivas or the appliances, this applies to us. Yes, now coming to today's topic on boiler, efficient boiler and operation of boilers. Now, as a still there is a problem. If you say that so many things, you have said that so many PAT cycles are there, a lot of things has been done, so many energy saving is done, still there is some problem. Now because from industry perspective, when you are implementing one recommendation, yes, energy saving is achieved, you are okay with that. But from the, what do you say, and productivity analyst side, we see it in a different way, right? So, and I think this is important to discuss with you. See, energy efficiency recommendation, if we categorize, there are 4 types or 4 ways in which we can achieve the energy efficiency. One is O&M control. Aapka boiler temperature is above the design or 530 se is increasing. There is no meaning of that. So there is a drop in temperature. So these are basically pressure drop, pressure changes. These are basically O&M controls. There is second way is retrofitting. Retrofitting means there you have already an equipment. You are just changing a part of it so that the efficiency improves. And plant में हम लोग ये करते हैं. There is a pump, there is a motor. What we do? अरे ये inefficient motor को हटा दीजिए, IE3 motor लाके लगा देते हैं. We do it. करते हैं सर? करते हैं ना सर? VFD लगाते हैं. VFD नहीं लगाते सर. कुछ motors में VFD लगाते हैं. So these are the retrofitting projects. We are not touching the system. Only a small part we are attaching to it so that the energy efficiency is improved. Third way is equipment change. नहीं ये pump inefficient ही है, इसको पूरा हटा दो, नया लगा देते हैं. Fourth is the process change. Now, what we did, 20 industries, 20 large-scale industries, the energy saving recommendations pattern we studied. 7 from the steel and iron sector, 9 from the thermal power stations, 2 from the cements, 2 from the buildings. So from different category we studied. Now this is the result, that 36% recommendations, because when under the PAT scheme, when you conduct the energy audit, the auditor will give you a report with certain number of recommendations. Now you have to comply to those recommendations, then file the form 3, then a M&V expert will come and check. Now about 36% recommendations are on O&M control. 42% recommendation are on retrofitting. 20% on equipment change, 2% is process change. I also agree process change is difficult. Okay. Now, in the other 3, 80% is coming from O&M control and retrofits, which is not a good sign. Why? Yes, sir. Because PAT scheme you saw from 2022, so 10 साल चला गया, 10 साल खत्म हो गया. So when after 10 years, when we see 40% is from O&M, we are not happy. आप बॉयलर प्रेशर चेंज कर दो, PRDS क्या क्रॉस प्रेशर ड्रॉप कम कर दो, आप बॉयलर का एक BAP का एक स्टेज हटा दो, प्रेशर रिड्यूस कर दो. नो, दिस रिकमेंडेशंस ये तो पहले से हो जाना चाहिए था. क्या सर, आप एग्री नहीं करते हैं? यस सर. ठीक ना. So thing is, after 10 years, हमें what we say in when we conduct a research, we say inefficiency locking. Inefficiency locking means अभी एक scheme आया है regarding replacement of inefficient fans. BLDC fans आए ना, brushless DC motors, जो घर में जो ceiling fans चल रहे थे. So old ceiling fans are of 70 watts, 65 to 70 watts. अभी जो BLDC फैंस आए हैं 30 watts के आसपास आ रहे हैं. So we say it is very difficult to implement and it is because of inefficiency locking. Inefficiency locking means, सर सच में बताइए, घर में कितना सीलिंग फैंस लास्ट 10 years में हमने चेंज किया है? So हमारा भुवनेश्वर में जो घर है, पुराना घर है, पिताजी ने बनाया था. हमने तो एक भी चेंज नहीं किया है. बाई चांस एक खराब हो जाता है, उसको रिवाइंडिंग ही करा देते हैं. सो दैट इज इनएफिशिएंसी लॉकिंग. वंस यू बाई, इट इज गोइंग टू स्टे देयर फॉर अनदर 30-40 years. So even you, for instance, for at the momentary cost difference, if I am choosing an inefficient product, it will be there for another 30 years. Same for industries. For O&M control and retrofit. Retrofit, I agree. Retrofit, lot of things we cannot foresee. There are lot of operational changes. VFD लगाए कहाँ पे? वो yes, I agree. There are lot of flow change requirements, pressure change requirements. We are going for VFD is okay. But I have seen places where you don't require system change also, but you have put a VFD. Because you have over-designed it. So the O&M control and the retrofit is because of the mistakes during the design stage, mainly. Now, that is what, after 10 years also of the scheme, if 80% recommendation is into retrofit and O&M control, equipment change in industries, maybe you can say about the efficiency pump replacement or compressor replacement. Right? In terms of boiler, what is the age of boiler? 25 years तो वो CA का किताब में लिखा है. टैरिफ ये वाला ने उन्होंने लिख दिया 25 years. अभी आपको भिलाई का बताइए एज. अब तो वो चलना ही नहीं चाहिए. वो तो चलना ही नहीं चाहिए सर. Sir, in 2010, I was doing an audit in West Bengal. West Bengal में there is a Chinakudi thermal power station. In Asansol area, there is a company called Chinakudi thermal power station. It was a 4.2 megawatt power station, and great firing, spreader stroker wala. 4.2 megawatt derated to 2.2 megawatt. And that plant was commissioned in 1910. So 100 years. After 100 years, we were conducting energy audit of that plant. Because that plant was set up by the Britishers for supplying electricity to the coal miners. So they have an agreement with the coal miners that you give us coal, we will give you electricity. So that time they were getting a coal which is having GCV of 5,200. Heat rate is about 5,000. Right, sir? So, yes, because it is the agreement between the miner and the supplier. Right? Yes.
Battery change.
Okay. Now, after certain years, of course, that plant was set up by English Electrics. Now that company also doesn't exist. So they have replaced it with another 12 megawatt power plant. It is okay. But what I am saying is the inefficiency locking. Similar story, we were doing the mandatory energy audit under PAD scheme at Vizag steel plant. Right, sir? So they have also captive power plant similar to you. That time, it was in 2013 or 14. We did not have expertise on the blast furnace. I do not know how to do the energy balance of a blast furnace. Nowadays, a lot of softwares have come up, I agree. But exactly analyzing the energy process, we don't have the expert. So we have to bring in a process expert. The other accessories, we were doing it. So we tied up with a European company, and they came in, and we thought, okay, we will work with them. So with 1 or 2 audits, we will also learn the steel making process, and we will recommend something. Now during that, the way they conducted audit, we were like, the client is not going to accept. Right? The way they say, okay, thermal power plant, you have a captive power plant, your heat rate is 3,200. Your heat rate is 3,200, and it is more than 37 years old. So replace the power plant. Right? So that is their recommendation, because they see the systems in their way. But we do know our economy is not that strong that we will go on replacing all these equipments. Right? So our recommendation is of nature like, okay, plant heat rate is this much, boiler BFP efficiency is this, so let us do some manipulation with the BFP. Okay, the HP heater is out of service, let us do something with the HP heater. LP heater performance is not okay, let us do overhauling of so many pumps. So our recommendation nature is like this. But they see the energy problem is different. They say, okay, this plant is not performing. If the power plant efficiency is low, their logic is, what is the point by measuring each and every pump efficiency when your entire plant efficiency is low? But our economic condition is different. But from this, we need to change. Now, okay. You see the implementation part. That was the recommendation part. In the implementation part, 28% recommendations implemented in the one day, 41% in terms of retrofitting, 31% in terms of equipment change. This 31 and 41 we'll discuss. Process change 0. Nobody is accepting the process change recommendations. Right, sir? So, frankly speaking, process change हम लोग नहीं करते हैं. Plant में हम लोग करते हैं? Yes, sir? See, process change, when we say process change, people will convince, okay, process change, मेरा blast furnace में कुछ करने वाला है. नहीं करेंगे, बंद. But pipeline जा रहा है water का, ले लो tapping. Sir, that is also a process change. When there is a pipeline, when pumps are operating in parallel, you are taking number of tappings, the pump efficiency will go down. That is also a process change. Compressed air pipeline, you are going extending. That is also a process change. Right, sir? Retrofitting and change in equipment, the recommendation implementation is a little bit higher because of introduction of the IE3 motors, energy efficient pumps, all these things. Even, as I said, there was a building in this category. So because of LED change, there is an impact in terms of equipment change. Retrofitting because of VFD. Now, coming to the boilers, boiler performance. So, boiler performance in our plant, how we carry out? We carry out through some standards. So we have ASME PTC 4.1 or IS standard. So as per the ASME PTC standard, we follow the or carry out the boiler efficiency part. Or if you see the BE guidelines, there is direct method, that is input-out method. Another is indirect method through the heat loss method. So direct method, we are only looking at the output versus input. Output is, boiler output is my steam. Steam is having some energy. So how we find out that energy? At that pressure and temperature, how much kilocalorie energy it is carrying, that is the output. For input, I know the fuel. If it is coal, quantum of coal into GCV is the energy input. If it is oil or gas, quantum of energy into GCVs or NCV is the quantum of energy. Now, direct method we use, but most frequently we use the indirect method, because in indirect method we evaluate all the type of losses. So when we see all the losses, we can see on which parameter can be controlled, which parameter can be brought down. So we evaluate all the losses, 100 minus all the losses, you get the boiler efficiency. This is indirect method. So in indirect method, direct method, this is the very simple, output divided by input. Output is nothing but your steam flow rate into enthalpy of the steam minus enthalpy of the feed water, because the water coming into the boiler is also carrying certain amount of energy. So that difference is actually the energy added in the boiler. Right, sir? So output is the only energy added in the boiler, divided by energy input is the quantum of energy fired to the boiler. That is direct method. Indirect method, we measure all the losses, then find out what is the quantum of efficiency. First one is dry flue gas loss. What is dry flue gas loss? So when we do a process mapping of a boiler, to the boiler we are giving how many inputs? We are giving 3 inputs. What are those 3 inputs? Air, fuel, water. These 3 are the inputs to the boiler. And when we see the output, the water goes out as a steam. So it is in the closed cycle. Only loss is that blow down part, that we will discuss separately. When we are doing the ASME PTC 4.2 method of efficiency evaluation, that time blow down valve has to be closed. So 3 घंटे का अगर जो test time रहता है, during that time the blow down valve has to be closed. That is why the ASME PTC 4.1 does not speak about blow down loss. They don't consider blow down as a loss, because that time your blow down valve is closed. But during the running condition, depends on your water treatment plant efficiency, you have to give the blow down. Now, that is the water cycle. So now water is in the closed cycle. Now there are 2 inputs, that is your air and the fuel. Now the air is at the ambient temperature, goes in and it comes out as flue gas through the chimney at a higher temperature. Because any matter, the quantum of energy content can be only 2 types. It can be sensible heat or it can be a latent heat. So the air, which is only gaining temperature during the combustion process and going out through the chimney, it is only gaining the sensible heat. So quantum of heat carried away by the flue gas is nothing but dry flue gas loss. Why dry? Because sensible heat, the moisture will have the sensible and the latent part. So only this is the dry flue gas loss. So quantum of air goes in, takes up heat, goes at a higher temperature. Right, sir? Now, H2 loss. What is H2 loss? Hydrogen present in the fuel. What hydrogen does? H2O. बट हाइड्रोजन को तो हम लोग ग्रीन फ्यूल बोल रहे हैं ना सर. तो यहाँ पे लॉस कैसे बोलेंगे? Yes.
हीट लॉस बन के चला जाता है।
हाँ.
इनहेरेंट मॉइस्चर जो रहता है वो हाई टेम्परेचर में वो कार्बन का हाई टेम्परेचर में उसका ये कार्बन के साथ प्रेजेंट करके वो उसको फ्यूल की तरह जलता है जो प्लस माइनस होता है।
That I agree. जो जला, that will generate heat. That is an addition to the boiler. But मैं loss किसको बोल रहा हूँ? Yes. So हाइड्रोजन जो कंबस्शन हुआ, मान लीजिए फ्यूल में 4% हाइड्रोजन है. Let us assume a fuel is having 4% of hydrogen. That hydrogen will burn. Now that hydrogen, when it burns, it will generate heat. But what happens is when that burns, it will produce H2O. That H2O is having two types of heat. It is having the sensible heat and the latent heat. The sensible heat can be transferred to the process, but latent heat you cannot transfer. Right, sir? So that H2O which goes out with the flue gas will carry the latent heat also. That is the H2 loss. Because sensible heat, I agree, it can be transferred to the process, but the latent heat part cannot be transferred. So that H2 loss is basically the latent heat loss which is not available to the process. So that is why you may be aware that in coal, all the efficiency calculations we do it in terms of GCV, gross calorific value. But in terms of gases, we conduct in terms of NCV, net calorific value. Why? Because of the difference of hydrogen content from the solid fuel to the gaseous fuels. Because the quantum of hydrogen is more in gaseous fuels. That means more quantum of H2O will be formed and more latent heat will be absorbed, which is not available to the process. So that is why we do it in the NCV pattern. That is the hydrogen loss. And as you said, there are other moisture present in the fuel. If coal is carrying some quantity of moisture, yes, that will also take the latent heat plus sensible heat, because that water is at ambient temperature. It will go into the furnace, it will gain the sensible heat, then latent heat, then go out as a vapor. So H2 loss, moisture in fuel, then moisture in air. Because of the relative humidity, you have also moisture in air. So what heat it will carry? It will carry only the sensible heat, because in moisture in air is already in the vapor phase. It is already in the vapor phase, so it will carry only the sensible part and go away. CO loss, incomplete combustion. So the oil, or sorry, the fuel and the air. Fuel basically it is a exothermic reaction. Carbon combines with oxygen producing carbon dioxide. Hydrogen combines with oxygen producing H2O. Sulfur combines with oxygen producing sulfur dioxide. Only these three chemical exothermic reactions take place during the process of combustion, and they produce energy. No other chemical reaction produces energy. Now, coming to CO. So when you are firing 1 kg of coal, it is, let us say it is having about 30% of carbon. So fixed carbon quantity is 30%. So 30% in 1 kg, 300 grams is carbon. But what we are supplying for the combustion process, it requires carbon and oxygen. But in place of oxygen, we are supplying air. Air is having only 23% of oxygen. So this 230 grams per kg of air and the 300 grams per kg of coal has to properly mix to produce the quantum of heat. Now this proper mixing in a boiler, there is a firing mechanism and a draft system. These two ensure proper mixing of coal and air for producing the energy. Now if the proper mixing of coal and air is not there, you will see carbon monoxide. Now carbon monoxide means it is a partial combustion. Partial combustion means how much energy loss? Now 1 kg carbon, if it completely burns, it will produce about 5800 kilocalorie of energy. If it is conversion to CO, it will generate about 2500. So about 4500 kilocalories loss because of the partial combustion. Then ash loss, if it is coal, there will be the bottom ash and the fly ash. So the ash coming out of the boiler will have some quantity of unburnt present in it. Now, why unburnt? Yes. Air fuel mixture, first it will reflect in CO and the carbon content in the bottom ash or the fly ash. The second factor is the size of the coal particles. So size of the coal particles, if you see the technological development of boilers, it started with the spreader stroker boiler. उससे पहले तो hand firing, coal engine में hand firing करते थे ना, so that is hand firing coal. Whatever lump size comes, you just put into the furnace chamber. Hand sizing, spreader stroker, then yes, now it is pulverized came, and after pulverized, the AFBC, PFBC is coming. So you see till pulverization technology, where you have 70% passing through 200 mesh, 75 micron size coal. So up to that, you see the coal size was coming down and coming down. So why? Now because we see when we bring down the coal, there is a high chances of carbon particle combining with oxygen producing carbon dioxide. That is why more quantum of heat was produced up to the pulverized technology. But what happened, again from pulverized to CFBC, we are increasing the coal size. CFBC 6 to 10 mm coal size. यहाँ पे CFBC है? नहीं है. So CFBC coal boiler is having 6 to 10 mm size of coal. But what brought in the fact कि हम लोग फाइन कोल से अगेन हायर साइज कोल में जा रहे हैं. So the more the fine the coal, you require more electrical energy for pulverization in the mills. So there is an energy balance. Quantum of energy you spent for creating the fines. Now when you burn it, more than that you should get. But when your ash content is as high as 45%, so when for every kg of coal, you are grinding 450 grams of ash. So to avoid that, higher coal size. Now because of coal quality only, we have gone for CFBC boilers. Other advantages are there also, we will discuss. Now, surface loss, the last loss, that is the radiation and convection loss from the surface of the boiler. So this is very easy. The calculation method is also easy. I will not go into the calculation methods. We will discuss some case studies. So basically, what data you require for the efficiency calculation? All this data we every day measure in the power plant, in the boilers. You require the ultimate analysis of coal. Ultimate analysis coal is nothing but carbon, hydrogen, oxygen, nitrogen, sulfur, H2 and ash. If you have a facility to conduct the proximate, you don't have the facility to conduct the ultimate analysis, you can conduct the proximate analysis, and there is a empirical formula to find out all these factors. You want ultimate analysis of the fuel, GCV, oxygen of the fuel flue gas. Oxygen in the flue gas, basically at normally for boiler part, we say oxygen after eco exit. Oxygen at the eco exit. So there is an oxygen probe. During the energy audit also, we bring in our probe, we measure the oxygen at the eco exit. Because after eco exit, there is no role of the O2. So 3 to 4% is excess oxygen we require, because we want to maintain 20% of excess air to ensure the proper mixing of coal and air. CO in the flue gas, if the mixing is not proper, or most of the cases, even though there is excess oxygen, you will see CO also. Then temperature, ambient temperature, humidity, combustible in fly ash and bottom ash. Only these data we require for the efficiency evaluation of the boiler. Right, sir? So what instruments we require? We require a flue gas analyzer, temperature indicator, draft gauge, and a flow meter. If these data are with us, then we can find out. Of course, for indirect, we don't require the flow meter also. If you have a pitot tube also, that is also fine, because for airflow we need to measure. Water flow meter is not required. If you use pitot tube also, that is also fine. Now in the duct, the measurement, जो ऑक्सीजन प्रोब है हमारा तो फिक्स्ड है, zirconia probe. Now that may not give a proper reading also. Sometimes there can be a stagnation of flow gas at that location. So that is why always advisable that you carry out sample testing at different intervals. आपका ऑर्सेट apparatus हो या फिर अगर पोर्टेबल फ्लू गया, पहले तो ऑर्सेट apparatus होता था, हम लोग लेके जाते थे, बहुत डिफिकल्ट है वो लेके जाना फील्ड पे. आजकल तो पोर्टेबल फ्लू गैस एनालाइजर आ रहा है. So you can just be careful about the sampling techniques. If it is a square duct, how samples you have to take. If it is a circular, how to take the samples. Then the specification, these things also okay. The data sheet, and finally the efficiency evaluation. As I said, only the ultimate analysis of fuel required. This is the oil example, oil-fired boiler. So that is the GCV, then the steam pressure, enthalpy, feed water temperature, the oxygen in the flue gas, CO2 percentage. So oxygen or CO2 is either is okay. Either you measure the CO2 or you measure the oxygen. Normally you have the oxygen probe, so you take the O2 measurements. Then the flue gas temperature, ambient temperature, humidity of air. These are the input data. This is little bit calculation. First is basically the stoichiometric calculation. Stoichiometric calculation means quantum of air required for your fuel. Because for you every shift the fuel quality is changing. So if every time the fuel quality is changing, the quantum of air requirement also changes. But at present what control we have? Are we calculating the excess air, theoretical air in plant? No. Then what is the control mechanism? How we are doing the adjustments? Let us say today the coal is coming at 3500 GCV. Tomorrow there is another coal which is coming at 4000 GCV. Yes. So for us, we are only looking at the O2. Whatever variation in the coal quality may be, we have to maintain 3% O2. कैसे होगा सर? You see, even in your bike, there is an accelerator. So when the accelerator is at nil position, there is certain quantity of fuel going into the engine, certain quantity of air is being injected into the engine. When you are increasing the accelerator, the quantum of fuel input into the engine and the air input to engine is increasing. But after a point, the accelerator is stopped. There is no further movement. Why? Because that is the range in which the air-fuel ratio remains constant. So you go at 40 km speed, the excess air quantity is same. You go at 60 km speed, your excess air quantity is same. Because when your engine volume is constant, either when you increase the fuel quantity, you have to compromise in terms of air. Volume to same है ना cylinder में, right sir? So that is the operational range. Similarly for boiler, आज 3000 आया, कल 5000 आया, but मैं वही 3% ही देख रहा हूँ ना, right sir? So it's fine. There is no, मैं ये नहीं बोल रहा हूँ कि वो गलत है. No, it's not. But we also should evaluate the quantum of air, because most of the cases, what happens, O2 is, as I said, O2 is not the final indicator. Right? Because in one of the case study we will discuss. So this is the theoretical air calculation. Then you measure the O2, find out the quantum of excess air. That means if you have 3% O2 O2 by 21 minus O2. So 3 by 21 minus O2. That is the percentage of excess air you are supplying into the boiler. So 20% excess air is fine to ensure the solid fuel, but for if it is gaseous fuels, you have to further bring down. Then quantum of flue gas into MCP delta T, because it is taking sensible heat only. So quantum of flue gas is nothing but quantum of air plus non-ash portion of the oil of the fuel. फ्लू गैस में कहाँ का जो एयर एंड फ्यूल इनपुट हुआ, कोल एंड एयर इनपुट हुआ बॉयलर में. सो एयर का कुछ पोर्शन, एयर का एंटायर पोर्शन, फ्यूल का कुछ पोर्शन विल गो इनटू द फ्लू गैस, रिमेनिंग पार्ट विल कम एज एश. सो दैट मास multiplied by Cp delta T, specific to delta T, is nothing but quantum of heat in the flue gas. Okay. Then because of hydrogen, you see, hydrogen, as I said, it will take both latent heat as well as the sensible heat. So latent heat, how we calculate? M delta H, mass of water into delta H is latent heat of water, plus Cp delta T, sensible part it will take. So for mass of water, it is basically 9H2. 9H2, why? Hydrogen will combine with oxygen producing H2O. So 1 kg of hydrogen will produce 9 kg of water. That is why it is 9H2. So it gives you the mass of water. 584 plus Cp delta T. 584 is the latent heat. At atmospheric pressure, what is the latent heat of water? Yes, sir? 540 kilocalorie per kg. So at atmospheric pressure, it is 540 kilocalorie per kg. Now, if it is 540 per kg, why it is 584? Because the combustion is at a slight negative pressure. So if you see the enthalpy diagram of steam, it is a bell curve. So you reduce the pressure, more quantity of latent heat is required. That is the technology for supercritical, no? Supercritical, because in power plant we are not able to use the latent heat part. So in supercritical, you increase the pressure to 321 bar. That is the critical point. So you don't require to supply the latent heat to the boiler. So that gives you addition in the plant efficiency. So when your pressure is low, your latent heat will increase. Then of course the humidity part. When you add all the losses, bottom ash losses, fly ash losses, sensible heat losses, moisture losses, hydrogen, so you add, you will get the boiler efficiency. Now in this case, there is a PG test data. Most of the हमारे जैसे प्लांट हैं बॉयलर में डिज़ाइन डेटा मिलना थोड़ा मुश्किल हो जाता है. PG test report रहता है, right sir? So you have a PG test data, you have an average efficiency. So there is about what do you call 1% के आसपास there is a drop in efficiency, right sir? Now the other PDF एक अपन किशोर थोड़ा देख लो. Now evaluation is simple. Evaluation, just we discuss the formulas, but one Excel you prepare, it will automatically calculate. Now coming to the interpretation of those results, standard says this much. The ASME PTC 4.1 that we discussed, this says about this process, this how to calculate all these losses, what are the formulas, what is the efficiency. But now as an engineer we have to interpret, because we cannot go by the European recommendation, now let us change the boiler. हो सकता है क्या sir? So we have to see the controllable parameters. All the losses are not in our control. There are some uncontrollable losses, there are some controllable losses. What are the uncontrollable losses? What are the uncontrollable losses? Hydrogen is a controllable or uncontrollable? You can't do anything. Moisture in fuel, uncontrollable losses. Then what else? Radiation, little bit in control, but it is insignificant, it's okay. Then, yes sir? Flue gas is a controllable loss. If I control the quantum of or the temperature of flue gas, then it is a controllable loss. That is the limiting factor because of the dew point of sulfur. So as I said, no, we were discussing that in NCV, GCV. So NCV, GCV difference is that the hydrogen will go in the vapor form. Now if we bring down the temperature below 180, there is a chances that the sulfur dioxide will combine with the H2O producing sulfuric dioxide corroding the duct and chimney. So that is why we higher than the 100. 200 is also okay. So that is the limiting factor, but it is not that what 260 or 270, no. Now, then the ash is a controllable loss. Standard says this much, but let us see how we interpret all the results. The word file. Yeah, little large, expand. Yeah, this is a, you see, this is a 210 megawatt power plant. Unit loading is 80%. So when we conduct the trial, we also ensure that it is above 75% loaded, because the loading will also have an impact on the efficiency. So loading is 84%. Steam flow is about 82% of the MCR. Next. You see all the losses, bottom ash losses, fly ash losses, then the sensible heat loss to the flue gas, moisture and hydrogen loss, moisture in air, surface heat loss, total loss. So 87.8 was the design, 86.7 is the actual. So still all about 1% you can say, because there can be calculation errors and there are some assumptions. This what you call the surface and radiation losses, it is difficult to measure. Now come down. Now first interpretation, जो 1% कम हुआ in terms of boiler efficiency, blame यहीं पे डाल दो. किसके ऊपर ब्लेम जाएगा? यस सर, जो 1% बॉयलर है, 1% ही है ना, किसके ऊपर ब्लेम जाएगा? कोयला खराब है. So this is the design of 210 megawatt power plant, 5000 kilocalorie per kg. We are operating at 3500. So 1500 kilocalorie कम है, तो यहीं पे ब्लेम डाल सकते हैं. क्यों सर? एग्री करते हैं या नहीं सर? होना तो चाहिए कुछ कम ना सर? है, of course I agree, but not fully. Now, just a second. You see the carbon percentage, the quantum of carbon 48 to 36, hydrogen 2.9 to 2.1, sulfur 0.5. It is okay. See, the fixed carbon quantities has come down, right sir? When the fixed carbon quantity has come down, basically that means there is increase in the ash quantity. So ash quantity means you will have problem in the mills, right sir? So if you have problem in the mills, then you cannot simply put the blame on the coal quality. Coal quality I accept, which is one of the factor. Let us go down. Number one, the other reasons you see, absence of HP heater and the economizer performance. See, the the economizer is designed to take feed water at about 245 degrees centigrade. So after completing the turbine cycle, the feed water inlet temperature to the economizer has to be 245 degrees centigrade. बट प्लांट में क्या हुआ ना, टर्बाइन साइकिल में एक एचपी हीटर आउट है. जब एक एचपी हीटर आउट है, सो दिस फीड वाटर इज गोइंग एट 184 डिग्री सेंटीग्रेड. So the boiler now has to perform the work of HP heater also. HP heater was in the turbine cycle, but now when the HP heater is out, the work has been transferred to the boiler. So ठीक है, heat transfer we can say वहाँ होना था, यहाँ हो गया. कोई भी एक हीटर्स में, बिकॉज यू सी द टर्बाइन साइकिल, ये एचपी हीटर, इकोनोमाइजर, सुपर हीटर, रीहीटर सभी तो एक सीरीज में ही है. तो एक हीटर आउट है, दूसरा ने लोड ले लिया, ठीक है ना सर. बट इट इज नॉट लाइक दैट. नाउ नेक्स्ट, सो दिस इज वन अनदर प्रॉब्लम. नेक्स्ट, so this will increase the thermal loading of the economizer. So when the thermal stress increases, there will be failures. Next, tube failure. थोड़ा नीचे आइए, थोड़ा. You see, these are the number of outages because of tube leakages. Boiler tube leakage. ट्यूब लीकेज का ब्लेम किसके ऊपर जाएगा? सो अबाउट यू सी ऑपरेटिंग एट 175 मेगावाट, टोटल जनरेशन इज 83 मिलियन यूनिट्स बिकॉज ऑफ ओनली बीटीएल. सो बॉयलर ट्यूब लीकेज, when we do the indirect method efficiency, showing all these, why I am showing is this is not reflected in the standard. ये because of this BTL, whatever loss we have incurred, this is not reflected in the ASME PTC 4.1. उसमें तो ये कैलकुलेट नहीं हुआ है. Now, all these tube leakages are because of two reasons. Either ट्यूब इनसाइड में कुछ प्रॉब्लम है, या फिर ट्यूब आउटसाइड में कुछ प्रॉब्लम है. ट्यूब इनसाइड में देयर इज वाटर रिलेटेड प्रॉब्लम, अगर आउटसाइड है तो शूट ब्लोअर. वाटर रिलेटेड तो हम लोग थोड़ा कंट्रोल कर लेते हैं, शूट ब्लोइंग में थोड़ा. चलिए नेक्स्ट. Okay, boiler water related. Controllable losses in the fly ash or bottom ash. In the bottom ash or fly ash, if there is a unburnt quantity is high, there are two reasons only. The draft is not proper. Second, the mill performance is not as per the mark. There are only two reasons. Now, draft is proper means not proper means either the proper mixing is not proper or the residence time being available to the coal particle is not proper. So once a coal particle enters the furnace zone, it has to burn completely, then come out of the furnace. So there is a residence time required for each particle for complete combustion. So if draft is not proper, that means either there is a proper mixing of C and O is not there, or the residence time for every particle is not uniform. Second reason, mill performance. 5 mills operating, 70% must pass through the 200 mesh. So only okay, B mill is 84, okay, C mill is 71, okay, but all three mills are not performing up to the fuel requirement. So that is why the bottom ash and the fly ash loss will increase. Right, sir? So next. So these are basically this interpretation how we perform the energy audit. Again, this is the performance of the air preheater. आपका जब economizer में the feed water temperature was lower than the design. So the heat gain in the HP heater was transferred to economizer. In the economizer, when the feed water gains more temperature, the flue gas temperature will drop. Now when the flue gas temperature drops, for the air preheater, your inlet flue gas temperature will drop. So economizer के वजह से air preheater performance will also come down. Yes sir? Okay. So that is why air preheater performance is also required. Next, another case study, the PDF. See the second case study, little expand it and next page. These are the data collected during the audit process. This case study is a integrated steel plant, similar to yours. Next page. It is a 60 megawatt unit, CFBC boiler. Next page. It's okay, it's okay. You go to the next page. Because why I am showing you? Because only the standard and evaluation is easy. Once you have to see the standard, prepare the Excel. But there are a lot of interpretation problems. You see, this is a 60 megawatt unit. Just go down. Yeah, just okay. Now you tell me, as an energy auditor, what we will recommend here. You see the losses, what we discussed. What recommendation we will bring in? You see it is a 60 megawatt unit, 100% loading, steam flow as per the design, NCR 100%, unburnt loss is almost okay, sensible heat loss is less, CO loss insignificant, H2 loss within the limits, moisture in ambient air within the limits, radiation and uncounted loss within the limits, boiler efficiency at par with design. Then what to do? Yes, sir? Bottom ash means slightly scope is there, I agree. But they had a major problem. You see the direct method? Yes, sir. Okay, CO की वजह से भी थोड़ा loss है 0.2, okay. But you see the direct method? Direct method mein we did, normally people don't do the direct method, but here we tried both the methods, direct and indirect. $77. Yes, sir. Feed water pressure. Feed enthalpy of pressure, yes, it is lower. 137 to 121, correct? But what to recommend? See, indirect method efficiency, as per the ASME PTC 4.1, we calculated 86.3. It is same as design. Direct method, but it is coming 77. So to leave it to operate like that, or what to do? Normally in industries, when we do a direct method as well as the indirect method, if the difference is 2 to 3% is fine. If it is more than 3%, then there is some issues. What issue can be? Sir? Calorific value. Fuel rate, you see 440141, okay, it is 200 kilocalories, nothing. See, there is a reaction known as Board-Odd reaction. Board-Odd reaction. Board-Odd reaction. Right, sir? Now, what happens is, just go down, yes. You see the economizer performance. You see the economizer performance. What is the temperature of feed water inlet? 335 design. 229 is the actual input. Feed water at economizer out, 298. Out is 321. So what can be the possible reasons? Secondary combustion. So that means because there is a residence time is too short, that there is carryover, there is secondary combustion, or there is bordered reaction, so that the CO whatever is being formed because of bordered reaction in the after the combustion zone, because oxygen is available, it is again burning out. Yes, sir. So because of post combustion, the combustion not in the furnace zone, this temperature is high in the economizer. The problem is, in the previous slide you saw, na, the feed water pressure is to 121. Now at 121 kg, this is reaching to the steam, the evaporation temperature. So the evaporation may start from the economizer itself. This is absence in ASME PTC 4.1. ASME PTC 4.1 is only, as per ASME PTC 4.1, my boiler is very fine. Right, sir? But we need to do component-wise analysis. That was the result process of this one. Okay, back to the presentation. Okay, so this is a normalization criteria because of fuel quality. When we say because of ash content ज़्यादा हो गया, बेकार हो गया GCV, उसके वजह से मेरा boiler efficiency down है. कितना down होगा because of that? This is the formula to calculate how much deterioration in the boiler efficiency because of fuel quality reduction. Energy conservation opportunities, whatever all we discussed. Yes. Now, I think I have crossed the limits, but coming to the final comments on the boiler performance. You see, all the schemes, or normally in energy efficiency when we see supply energy efficiency, end use efficiency, and lifestyle efficiency. What is lifestyle efficiency? Sir, I require ambient temperature of 25 degrees centigrade and relative humidity of 50 RH. That is my lifestyle requirement. To meet this, I need AC. So AC can run 24 hours, AC can run 8 hours, AC can run 3 hours also. That is depends on my lifestyle efficiency. To manufacture AC, and AC will have an efficiency of 90% or 95%, that is end use efficiency. And supply side, all the back-end activities for the AC operation and control, that is supply side efficiency. So all the policies till now what we discussed in the first slide, that in all 5 sectors, they speak about the supply side efficiency and the end use efficiency. There are guidelines for energy supplies, this e-certificate trading and everything. There are rating of appliances, all these things. But there is no guideline for lifestyle efficiency. So next decade will be for lifestyle efficiency. Right, sir? And what new things will come up in energy efficiency sector? That will be AI and data analytics. Now in energy efficiency, what we say, there are 3 types of services available. Okay. One is energy auditing and capacity training programs, that we are doing it, NPC is doing it, and industries are availing it. Second is ESCO services. ESCO services, one company will come and implement certain energy conservation activities in your company and you pay him. That is also there. But this automated energy performance monitoring, we have till now, we haven't gone into it, at least in our country. That is one thing. Second is design efficiency. Still now, we are least bothered on the design efficiency. Abhi bhi, we are see Energy Conservation Act is 20 years old. Still we are talking that, okay, let us construct a building and on the rooftop let us install a PV cells for generating electricity. In UAE, they are talking about building integrated photovoltaics. So the building construction will be with photovoltaics. where our thinking is let us construct the building, then let us use the rooftop for PV. Their idea is let us construct the building with PV. That is BIPV, Building Integrated Photovoltaic Design. So design stays efficiency and energy transition. Energy transition is again going to be the next chapter. So if there is no further question, I think I have exceeded my given time. If there is question, of course, we can discuss. Yes, sir? M&B experts, yes. In the energy auditing, there are three things. One is our energy manager, one is energy auditor, another is accredited energy auditor. So energy manager, the exam is being conducted. At the 4 papers you have to appear. If you pass 3 papers, you become an energy manager. And for every organization, it is mandatory to appoint an energy manager. Energy auditor who passes the 4th paper, he becomes an energy auditor. And an energy auditor, after 3 years of experience in energy auditing, he can apply for accreditation. When he applies, if his accreditation is approved, he can become an accredited energy auditor. Again, if you are conducting energy audit in steel and iron plant, so your accreditation will be for steel and iron sector only. Now, after completing this accreditation, you can be a M&B expert for steel and iron sector only. Okay. Monitoring and verification. Monitoring and verification. Yes, sir. So, yes, sir.
एक्चुअली सर आपने सर जो बताया कि जैसे सर बॉयलर ऑपरेशन में जैसे कोल रिलेटेड इश्यूज है, पर्टिकुलरली सर हमने केस देखे हैं कि राउरकेला पावर प्लांट में मतलब एनएसपीसीएल में वहाँ पे सर लो पीएम भी चलते हैं, बट जो बॉटम मिल में जो फ्लैम है वो टोटली आउट हो जाता है, जिसकी वजह से फ्लैम फेलियर की वजह से मैक्सिमम टाइम वहाँ पे कीपिंग हुआ है।
यस यस यस
सर इम्प्रूव करने के लिए क्या कर सकते हैं?
सर देखिए वहाँ एग्जैक्टली वहाँ पे दैट इज़ द प्रॉब्लम आई हैव ऑल्सो सीन। मैं आपका प्लांट में भी आया हूँ, अगेन नेक्स्ट महीने में भी आऊँगा। दैट प्रॉब्लम वी हैव सीन इट सर। उसके ऊपर हमारा कंट्रोल नहीं है सर। दैट इज़ व्हाट यू कॉल, देखिए जो हाई कार्बन कंटेंट कोल आते थे अर्लियर, दोज वो डिज़ाइंस वेयर देयर। अगर बीपीसीएल से कोई है क्या? बोकारो, हाँ, पहले डाउन शॉट फायर बॉयलर होता था आपका, इंस्टेड ऑफ द कॉर्नर फायरिंग बॉयलर। कॉर्नर में भी आपका डिफरेंट मिल से डिफरेंट एलिवेशन में कॉर्नर बर्नर से यू हैव फ्रंट, सामने से बर्नर रहेगा। सो जो सामने से बर्नर रहेगा इट विल हैव ए बर्नर डाउन एंड देन मूव अप। जो हाई कार्बन कंटेंट कोल है, व्हाट हैपेंस, इट रिक्वायर्स मोर रेसिडेंस टाइम फॉर कंप्लीट कंबस्शन। अगर वो रेसिडेंस टाइम नहीं मिलेगा वो नीचे आ जाएगा अनबर्न होके। अगर आप जैसे आपका केस में इफ़ यू प्रोवाइड मोर रेसिडेंस टाइम, टेम्परेचर विल फॉल, तो आप वहाँ पे कर नहीं सकते, आपको अनबर्न के साथ निकालना ही पड़ेगा। दैट बिकम्स योर कंस्ट्रेंट। टू कंट्रोल दैट, जो डाउन शॉट फायर्ड बॉयलर है दे वर डिजाइन टू हैंडल हाई क्वांटम ऑफ कार्बन कोल। सो जो डाउन में जाएगा अगेन अप मूव होगा। सो देयर यू इंक्रीज द रेसिडेंस टाइम, बट टैंजेंट फायरिंग में डिफिकल्ट। बर्नर टिल्टिंग से होता है, बट डाउन शॉट फायरिंग में इट गोज डाउन अगेन गोज अप। सो आपका दोनों बार बढ़ जाएगा, बट दैट इज द लिमिटेशन। बट 30 डिग्री से नहीं होगा सर, और ज़्यादा, बिकॉज ओनली दे हैव ओनली फ्रंट फेस में ही रहेगा बर्नर्स, बाकी साइड में कुछ नहीं है सर। नहीं देखिए, पार्शियल लोड में दैट इज वेरी देखिए पार्शियल लोड्स में इट इज डिफिकल्ट दैट देयर आर चांसेस कि जो प्रॉपर ड्राफ्ट ना होके देयर कैन बी फ्लेम आउटेजेस ऑल्सो। दैट इज वाई वो रिकमेंड करते हैं ये स्पेसिफिक टॉपिक में प्रवन जी विल हाईलाइट इन द सेकेंड सेशन, बिकॉज देयर बॉयलर हैज ए वेरी स्पेसिफिक इशू। मैं उनका प्लांट में गया था, they have captive power 135 megawatt into 6. It is connected to the their steel plant. So in the steel plant, they have induction furnaces. You take the tapping, load drops. So 135 megawatt, after 1 hour, 75 megawatt. Half an hour, 135 megawatt. Then another, after 1 hour, again 75 megawatt. I think you can discuss during the presentation. ठीक है ना sir? So thank you very much, sir. Thank you, sir.
Thank you, Abhijit, sir.